It's like saying Haaland is gonna go to. It's like when Haaland went to Manchester City. That's like the best comparison I can give you.
All right.
I hate that
How was your exam? How do you feel about your exam?
I thought that was the worst.
Okay. Okay. We're going to talk a lot about the exam. Okay, after this. Today we're going to go over only 4.5 optimization. Okay, we're going to practice. Okay, we're going to do a group work for this topic. Okay. This will mark the first section on your final. Okay, on your final. First section on the final will be this one. Okay, and more to come. Okay, more to come. But first one. Optimization. This basically the related rate. This is the related rate problems. Okay, these are related rate problems. Related rate combined with derivative test. Okay, related rate combined with derivative test. Related rate, you're gonna do some word problem, right? Triangle, car moving left, right, north, south, a ball, pumping water, pumping air, a can, a glass, a cone, pour something in, whatever that is. You calculate the volume or rate of change, right? That is a related rate. Okay, that was the related rate. And then you was asked to find something in there like either the, how fast did the radius increase, how fast did the height decrease, and so on, right? How fast is the car moving after 2 hours at 1 p.m. yesterday, right? At 1 p.m. Okay, so basically the same idea. But this time, instead of asking you how fast is this one moving, that one moving, increasing, decreasing, it's going to ask you what is the highest, what is the largest, what is the radius, so that you have the maximum volume. Okay, what is the speed, what is the velocity that you have to reach the destination the earliest, and so on. Okay, when you use those adjectives, like what do you call those adjectives? Earliest, soonest, those kind of adjectives. But how do you phrase that? What kind of adjective is that? Compare. If you compare, but the most comparison. What do you call that kind of adjective? Soonest, earliest, the most beautiful, the most successful. What kind of adjective is that? Come on, English 101, where's that? What's that? Okay, when you use those words, you're asking for the maximum and the minimum rate, the highest or the lowest. So this section is about that. Combine the related rate and that. So, therefore, because it is similar to the related rate, the frame is the same. Usually you split out, right? Given question, you divide. Right. Yesterday, I saw you put a frame like that. Very, very good. You draw, you label, you put in given, you put in question. Same idea. Draw a diagram, label, put in both given and unknowns. Given here, question over there. Okay. And then use given information to convert all unknown variables into one variable. This is going to be a little bit new. Okay, today. This one also the same. Find a formula based on the problem that connect all the information. Okay, yesterday the car moved to the north. Okay, heading north, heading southwest, something, right? That was the triangle. If you discuss a yard, a fence, a rectangular fence, something, you're gonna talk about the area of rectangle. If you discuss volume of a balloon, you have to recall the volume of the sphere, right? And so on, right? If you pour water in a can, if I want to maximize that can, that glass water, you're gonna recall the volume of cylinder, so on, right? So that is the this one right here, and then you take derivative both sides. Remember? So for the next maybe 2-3 minutes, I want you to recall, try to write as much as possible. What is the formula for each one of this? You need them. Okay, here's the one you need to figure out. Okay, try your best. Go ahead. Area of triangle. Pythagorean theorem, just yesterday, right? Pythagorean theorem. Rectangle, oh, easy, right? Circle. C means circumference, right? Circumference. And so on. Okay, try that. And these will be the one we're going to focus on. Okay. Okay. Start with the area of triangle. Oh, who want to go first? Area of triangle. Elena. Are you Elena or are you Elena? Elena, right?
No, Alana.
Huh?
Alana.
Alana. Okay. Area of triangle. Area of triangle. What do you think? I give you a half.
1/2.
Keep going.
Pi. Is it pi?
Pi will be the circle. If you the moment you say pi, it has to be something with circle. Base times height. Okay. Andrew. I'm starting to get the name. Okay. Pythagorean theorem.
A squared plus b squared equals c squared.
There. Okay. Given that C is the hypotenuse. Okay. Rectangle. I'm gonna have you. I pick this one. See? I'm so helpful. There. Okay. That's the privilege of being standing up here. I get to choose. Okay. Work your way up here. Then you choose yourself. Okay. Rachel. Circle.
Greater than 1/2 squared.
Drop the 1/2.
Oh, 5 squared.
Okay. Crystal. Circle. Circumference. I'm going to put the pi in there for sure because it's circle.
It's 4 pi r squared.
2 pi. Okay. If you put the square, okay. Why do you have this square? And also, one way to recognize the formula that we are working with, the dimension, area. You usually call area is square feet, right? Feet, right? If you put centimeter square, meter square, right? Let's say the radius is 1 centimeter. Then you put in here centimeter square. That's how you come out the square in the area, right? So there's going to be a cube over here. Somewhere has to be a cube over here so that you can return a cubic volume, right? The unit for the volume. Circumference. It's just the length around a circle, right? A circle like that, you cut it, become a string like that, right? Just that length. It's just one dimension. So you only need one. You need R, you don't need the square. If you square, you're going to have R square, you're going to have area. Okay. Cadence. Spear. Spear, what do you think? Yep, I have you. Okay, I'm going to have spear. That gives you, there's going to be a cubic somewhere in there. What do you think? Another number than 1. 4. There. Okay. So,
Isn't it R2?
RQ, yep. Thank you. Yeah, return the cubic. Now the box, Harry, you've been helping with cadence. Now help yourself. The box, Harry. Box. Okay, I'm gonna draw a box. I'll label that. There. Length, height, width. Okay. Volume. Oh, that. There. Okay. a cylinder is identified by two things. First would be the radius of the surface, the top or the bottom surface, the radius. Second would be the height of that cylinder. Okay. This one, you can derive this one. You don't need to memorize this. If you want to derive this one, if you want to, generate a formula for this, how do you do that? How do you generate a formula for a volume of something? The idea behind that. Okay, drop this one. Look at this one. Why this one? It is. And then you stack it, right? You multiply by the height. Think of it like a dish, like a plate, paper. 2 paper, you increase the thickness, right? 3 pieces of paper, 4 pieces of paper, 10 pieces of paper, 1,000,000 one of them, right? Easier, look at the dollar. Say. Think of that, a pack of 100 bills, right? Hot, holding in your hands. Can feel that, right? Okay, you can tell the thickness. That thickness multiplied by the area of either the top surface or the bottom surface, you get a volume. Same idea. So that's basically the idea for any kind of volume, basically. Okay, so now this, you want to find the area of this one, the surface, the top surface, or the bottom surface. Basically, that is a circle you multiply by the height. Then what would be the area of this one? Pi r square time. There you go. That's the volume. You don't need to memorize. Right? The idea behind volume. Okay, now surface area. This one also we can derive, but we're going to be a little bit trickier. Okay, think.
For the volume of the cylinder, you said it's cube, but then when you talk about the volume of the sphere, you said all volumes are always cube.
Yes, good observation. The volume of a sphere 4/3. Okay, whatever that number, that RQ I'm looking at, right? That RQ. If you have 1 centimeter, or let's say 2 centimeter, the radius is 2 centimeter. Put in there 2 cube centimeter cube 8 centimeter cube, which is correct unit for the volume, right? Cubic. Volume of a cylinder. Why we don't see the Q in there? Because there's an H. Pi r square times height. Give me maybe something like a radius. Give me a number. Any number. Huh? 3. Okay, 3 centimeter. It has to have a height, right? You need to. How high is this? 5? Plug in there. 5. Okay, pi there. Centimeter square. No, it's 2. It's 3. 5 centimeter. You see that? You see that? Pi, that is 9 times 5. 45 centimeter square times centimeter. We still have the cubic. Isn't there? Okay. Does this one give you a cube thing? 2. Let's say 2 by 2 by 2. A perfect cubic box. 2 centimeter times 2 centimeter times 2 centimeter. That is 8 centimeter cube. Okay. So consistent, right? All right. And actually this one, later on we're going to do this. The derivative of this one with respect to, okay, dv over dr, that would be 4/3 pi 3r square, right? Right? And then dr over dr, right? But that is 1. I cancel that number 3. That is 4 pi r square. That basically 2 times 2, actually 4 pi r square. What is that? 4 area of a circle. Somehow volume, derivative of volume, give you 4 area of a circle. Okay. Derivative will give you this. Right? Okay, after. But why? Why does it work like that? Okay, right. See something in there? Why does it work like that? That will be something for Calc 2. You're gonna learn. Okay. You drop a dimension. Okay. Using derivative to translate a dimension, to move between dimension. Upscale, descale. That's how you watch. Back in the day, they're very trendy. That they build 3D TV, and then you go to movie theater, right? They give you a class. Do they still have that now? The 3D classes, they still have the 3D format. I don't go watch movie theater, so, but I know that. Okay, they have a class. How did they do that thing? Looking at the 2D flat surface, but you see something kind of popping up. The processor using some voodoo in there, but there's a derivative in there. Okay, they translate the code, they translate that. Okay, and if you later on, any one of you gonna go into like a designer, some kind of designer, like a graphic designer, either in gaming, designing a game, 3D game, Call of Duty, whatever, or you design CAD. That means you design a house, architecture, building house, all of that. You have to understand this basic behind this, okay? And then design anything now, you have to be in 3D, right? Every engine, the motor, the battery, everything inside, any compartment inside a car, inside anything, okay? TV, anything have to be in 3D. How do they convert between 3D and then 2D and then, yeah, that. Everything is derivative. Okay. Now surface area. Surface area. Okay. Upper cylinder. Upper cylinder. Upper cylinder. Oh, actually, here. Oh, perfect. Cylinder. How many surfaces are there? 3. A top, a bottom, 2 circle, right? An area, 2 circle, which is 2 pi r square. Okay, that's easy. Now this one over here. This one over here. What they actually look like? A rectangle. Look at that cylinder, right? I cut that. I open it out. It turned into a rectangle. A rectangle, then, okay, to find an area of rectangle, I need 2 things, right? Area of rectangle, length, this, right? And this turn out to be, this side, the width, let's say the width, turn out to be the height, right? The height, one dimension, at least one side is going to be the height of the cylinder. So that will be the height. Okay. Okay. This one over here, this side. That would be that would be the circumference of the circle on the top, right? The circumference, 2 pi r. See, you don't need formula. You need to memorize. Think about the nature of that. Think about the nature. Not everything needs to be memorized. All right. Okay. Then optimization. This is the new thing in optimization. Everything we have so far, that was related rate, right? Very related rate. Optimization, you use the first or the second derivative to find the maximum or the minimum. So basically, you have to take derivative both sides, implicit differentiation, and find critical points, right? And then maximum. Okay. Okay, ready to go to an example? Let's do it. Okay, here 4,000 feet of metal fencings. So find a rectangular field. Okay. What are the dimensions of the field that has the largest area? Okay. For now, don't think about optimization or anything. I want you to think about in terms of related rate. So that means starting with draw something about this one. Label, and then do the same like yesterday you did. You put in here, you give me a given, you put in a question. Okay. You draw something, you label. Okay, try your best. What's the problem asking for? Draw, label, read the problems. There's only 3 sentences, but give you a lot of things. Basically, only one numbers. Okay. Let's say Eric. If I draw, what do I draw? I draw something. A rectangle. Okay. I have the freedom. They don't give you any specific letter for length, width, or height. So I can pick randomly anything, right? So how about I put length here, put width here, right? And it's labeled. What do I have? Given. What do I have?
The 4,000 feet of fencing.
Okay. Convert that to math.
The perimeter of the fence is 4,000 feet.
Yes, that is not area, right? If you, in other words, you can also look at the unit to give an idea. What do you have? If it's like that means they give you something with the area. They give you like this. That means they give you something in just one dimension. And in this case, it's just 4,000 feet perimeter. Okay. What do they want? What do they want? Go ahead, Andrew.
The dimensions.
The dimension.
Area.
But in this case, now we have specifically letter for dimension, which is
Length and width.
length and width. That's what we're looking for. Right? The dimension of that thing, length and width. And also the last question asks you for the maximum area. Just not any area. Area and the maximum. Okay. It could be any area. An area at the maximum. All right. Okay, so that's what related rate train us to do. Okay, we have that. Okay. So, next step, we're gonna write out the formula to connect all of them. But in this problem, usually we want to write down at least 2 formula. But let's start with the first one, because the question asks you to find the maximum area. So let's find out. Let's start with that. Area, right, length times width. We want to maximize this one. We want to maximize this one. In order to maximize this one, we need to maximize these two. We need to the dimension to maximize this one. Okay, here is the step. Back to the step right here. You have the formula. You use given information to convert all unknown variable into just one variable. Just one. Just one. Right now, you have 2. Length times width. Right? You want 1 only. Why do I need 1? Because then how do I find maximum? How do I find maximum area? The idea behind the maximum and the minimum thing, the derivative test. Before that derivative test, you need so let's climb the ladder. Derivative test down here. Okay, the maximum down here, right? Maximum means down here, derivative test right here. Before the derivative test, you need the critical points. Before that critical point, you need to do take derivative, let that equal 0, right? That is the game. Derivative, let that equal 0. Critical point, test, max and min. I need to take the derivative of this. There's two variables. How do I take the derivative? Right? That is the idea. You don't want to A prime right away. That's a product rule right there. So nope. And I don't know nothing about length and width. So I need to convert either length or width into just one number. Either length only or width only. Where do I get the information to do that? They give us for a reason. The perimeter is 4,000. Perimeter is 4,000. So that means I'm going to come back to this later. 4,000 perimeter, which is 2L, 2 width. There you go. You're going to use this information, right here, this information. Convert, that means you're going to solve for either L or width, your choice. How about I solve for width? I solve for width. Solve for width. First thing first, I see 2, 2, and 4,000. Okay. Make it simple. All right. 2, 2, 4,000. Divide both sides by 2. There you go. Width is just 2,000 minus L. Length. Okay. Now I'm going to bring this one. I'm going to replace to exactly this W right here. And now the area I have right now is going to be a one variable function. Area now length times 2,000 minus L. Right. That yellow is this yellow, right? Okay. Note right here. 2 variables. Now become 1 variable. And when you have 1 more variable, you take the derivative much easier, right? Okay, next step will be L times 2,000. I have 2,000 L minus L, right? So I have 1,999 to L. 1,999, okay. Right. 1,999 L. Write that down, write that down. Write 1,999 L. Write that. I'm not going to write that, but you write that.
Is it L squared?
Okay. You spoiled the fun. I'm waiting for everybody to write that down. Everybody write that? 1,999? Yes or no? You've been with me for nearly 1 month already. Yes or no? Where's the mistake? Small thing matters. Details matters. You multiply by W, and because W it is 2 things, you multiply to both of them. Okay. I don't know, countless time I see that. And that changed the whole thing, right? Just one minor mistake, tiny mistake, you change the whole problems. Okay, so not 1,999. Okay, you have that, that's area. Now it's just 1 variable, clearly. You can find the maximum of this one, right? Think of this. If I don't give you that, if I don't give you this, I think you can do this, right? Find local max. Everybody can do that, right? And suddenly reading this, am I saying, okay, it's so difficult. But reading this, find local max, what do? You can do that, right? Do that. Find local max. But this time in terms of L. Okay. And that is related rate combined with the derivative test. Okay. That's true. Either, and when you do this, this question is not about derivative test specifically, so you can pick either the first test or the second test. Okay, either the first one or the second one. Make sure you have the table. If you do the first one, first test, make sure you have the table with the arrows going up and down. What would be the critical point? Okay. You did 1999. Okay, okay. Good. What would be the critical points? Critical point. I'm gonna do the table. Critical points. Okay. So, formally, it's like this, right? Either that or this. 2000 minus 2L. Okay. To find the local max of that, it's relatively simple. You let that equal 0. Equals 0. L equal 1K. Okay, this is where my student usually make mistake. That's the length. Is that technically you got one dimension already? The length. 1,000. Technically feet. 1,000 feet. But the question asks you to find the dimension. The question right here. Find the dimension that has the largest area. So you have 1,000. 1,000. Can you conclude your answer right away? Can you conclude your answer? That is the dimension. Give me the largest area. Can you do that? Right here. Can you do that? Yet? No, right? That's just the critical points. You have 3 critical points. You either have this, or this, or neither, right? That is one of those. You don't know whether it's the minimum or maximum or neither. That is why you need the derivative test. So I would go for the first derivative test. That means I do the table. I'm gonna do both of them. Later on you just have to do one. Okay, I'm gonna do both of them. Okay, that means I have to do this thing. L A prime A 1K. Pick one on the left, smaller than 1K. 0. I'm gonna pick 0. I'm gonna test 0. For sure, I have positive, right? No, 0 with me. Hold on. Yeah, 0 give you 2,000. That is positive. Go up. I pick maybe 2,000. That would give me 4,000 negative 2,000. Okay, a negative. Clearly. Now I can confirm that 1,000 right there generate a local max. Okay. Any question here on this table? Do you know how to work through this table? Any question? Now I'm going to pause. This number, okay, 1,000. Understand, right? 0 and 2,000. Understand? It's just decimal. You can pick any number, right? I pick 0, I pick 2,000. I plug in positive, increasing, negative, decreasing. And look at this movement. You're going to have a local max right there. Okay. So therefore, when conclusion, now I'm going to make the conclusion. When the length is 1,000, the area, the maximum area is how much? 1,000,000. Why is that? You only have the length. I say some space. I cut some space over here. I'm going to fill in something. To find the area, you need two things, length and width. You have length right now. Where's the width? How do you find the width? Right here. The width, 2,000 minus 1,000. 1,000. 1,000. So the area is length times width, 10 to the power 6 feet square. 60, right? 30 here, 30 here, 60. Instead of writing 1,000,000, 10 to 6. Okay, that would be the feet. This one will be the feet. If you're keen on the unit. Notice something? Give me your comment about this field, this whatever that is, that area, that rectangle. What do you see about that?
It's a square.
It is a square. No matter the length you have, that is actually true, scientifically true. We just proved the science right there. No matter the length, how much is the length? Okay, whatever the length you have like this, the best to make, okay, to bend that length, bend that wire, whatever that, okay, that copper wire, whatever that is, in order to give you the max, to cover the maximum area. The best way to bend, the square, right? The square. This become a perfect square. That is a square. Okay. You don't want this one more than this one. You don't want either one of them more than the other. Make it a square, then that area inside will be the maximum. Okay. All right. Okay. So I did the first derivative test. I'm just going to throw in there the second derivative test for you. Okay. Second. This one much easier technically. It's always more superior than the first one. Take second derivative. Second derivative will give me -2, right? First derivative right there. Take the derivative of this one is -2. Just -2. Okay, what do I do with this one?
You can just say like at all points it's concave down.
Okay, right.
So then it's local max.
Uh-huh. We don't need to recall the concave. We just say it. And 0. Right? Clearly, -2 is a negative number. Therefore, usually the traditional way, right? We're going to plug in the critical point. That's also -2 because that is a constant. No matter the number that you plug in here, it's always give you -2, also less than 0. Therefore, okay, level. That's it. Second derivative test. Second derivative test always superior than the first one. You don't need to find 0. You don't need to plug in 2000. You don't need to draw the table. You get the answer right away. Okay. Length equal width. You have a square. Okay. There is also, okay, that area right here. There's one more surface, one more shape that also maximize the material that you make. Let's say I have a pile of mud, clay. I want to make into some shape that cover the most area given that, a clay I have right here in my hands. Okay, I'm gonna squeeze it, try to make some shape to cover the maximum area. What do you think the shape should be? A circle. A circle. Holding a pile. You squeeze that, you make that into a circle. It covers more area than, it's even more optimized than a square. Okay. Next one. That one done. A can hold 2 liter of juice. A can hold 2 liter of juice. That's a little too much. 2 liter is a little bit too much. Okay. 2 liter. No, I don't like the unit. Not realistic. That basically more than almost a gallon something. 200 millimeter better. Okay, I want to be as realistic as possible. Okay. Find the dimension that meets the minor cost. Okay, let's start with the framing this problem. Starting with the drawing, label, what's given, what would be the question. Given, something given to you, some question to you, okay? A can. I hope you know what does the can look like. What will be the drawing of a can. Then label that. Can. Okay, Ken. Right, Ken. Something like that. Okay. A can only defined by two things, two dimensions, a radius and a height. Okay. Given.
Volume.
The volume. 200 milliliter. Okay. Anything else given? No, right? That basically is it. That's it. And that's usually the real world problems, right? I just throw in there. I give you 200 millimeter. Okay, maximize the cost for me. Minimize the cost. Minimize, not maximize the cost. Minimize the cost. Minimize the cost. That means you maximize the profit, right? So you want to minimize the cost. Minimize the cost. Minimize the cost. Okay. What do they want from this? In order to minimize the cost, what do I want to minimize? Of course, to find the dimension. Ultimately, this is what they were looking for. Find those two. Previous problem, length and width, 1K each, a square. Last problem. This problem, the radius and the height of this one. Given that. But the radius and the height so that you have this. Think critically. As someone who's about to go to join the workforce in a couple of years. You work in a team, your boss gives you something like that. A can hold 200 millimeter, just this. I want you to minimize the cost to make this one. But at the same time, hold 200 millimeter. And actually, that, anybody have the, a Coke? Or any kind of can, that you finish, any can? Restaurant you finish? Bottom up. Bottom that up, bottom up. Halfway already or almost there?
Like half.
Half already? How about you?
It's pretty full.
Pretty full. Anyone? Can you bottom it out? You know, can you finish that? Yeah. Try your best. Try your best. Anyone else? Yeah, but keep going. If nobody. Yeah. I'm gonna borrow that. Okay. I don't want to go. Last semester I had to go to the trash can to dig up a can. But this semester, you got it. Okay. Take your time. No pressure.
Take the whole class.
Okay. Thank you. Appreciate it. There you go. I don't have to go to trash can this time. Okay. First one, shout out to Rachel. Okay. Second, why is it like this? Why not bigger like this? Thinner like this? Why have to be like this? Or the Coke? Why most of them look like this? Billions of dollars was spent just to think of this dimension. Okay, just about maybe a gram of 2 milligram of aluminum making this. Cost maybe less than half a cent. This one, the material costs less than a cent. But drop that one like 0.0 a cent, right? Material for this one, mostly that, around there. But if you able to drop that around this, drop that. That means you save, right? Around there. Not even. Am I doing the math correctly? No. I put 2 0. So 2 0. Okay. Just save this much. They make around 500 million per month. 500 million can like that per month. 500 million per month. Let's say 100. How much they save? That means 1, 2, that's 80. That's 80. Move this number to the right 8 times. Move this decimal, okay? So right here, 0, 0, 1, 5. 1, 2, 3, 4, 5, 6, 7, 8. There you go. 150,000. That much saving. Okay? That's just one. That's just one. Multiply that by 5. That's a month. Multiply that by 12. By 4. That's a quarter. Multiply that by 12. That's a year saving. Okay. So $1 billion the industry. Just a can of Coke. $1 billion industry. Now you drop. Back a day. Now it's easy now. But back a day. $1 billion just to think of that. Save that much in aluminum. Just a line, tiny aluminum. If you that. Okay. So how do I do that? How do we minimize the cost? Think. What do we want to minimize the cost? To save the cost, what do we want to minimize? Speak up.
Surface area.
There you go. Oh. Last semester, this is one of the questions I forced my students to think of, to get the answer. I didn't give the answer until they give it. It took them nearly half an hour to think about it. But today is good, okay? You want to minimize the surface area. That's basically the material to make the can. The less material to make this one, the less the cost, the more the profit. Minimize that. We're done. Because cost doesn't involve these two. But this not now. You want to minimize this one. This one has both of them. Surface area of a cylinder. So you want to minimize SA. And the surface area, we derived it a little bit earlier. That's 2 pi r, 2 pi r squared, plus 2 pi r h. Right. Two area of the circle, top and bottom, top and bottom, top and bottom. The area around the can. Okay. All right. We want to minimize this. I'm looking at most of these problems. You're looking at least 2 to 3 variables. I'm looking at R and I'm looking at H. One of them has to go in order to take derivative, right? To minimize this, we know the game now. Derivative, set that equals 0, critical point, derivative test, and done. Before all of that, it has to be one variable. Either R or H. The other one has to go away. Okay, 2 is 2, pi is pi, nothing there. Where do I find the information? Anything we haven't used? That's 200. Right. Use that 200. Last problem. You have the perimeter. This problem, you have 200 millimeter. Okay, so the volume is 200. That means pi r squared times h is 200. Volume equal 200. Volume is 2 pi r squared times h. Okay. Okay. Use that one to solve for either R or H. Pick one. Pick wisely. Solve for H. Right. Because next step, after you solve, what do? You plug in here. If you solve for r, you're gonna have to plug in two places, right here and here, right? Right. If you have r equal whatever, r equal, and even worse than that, see that as where? Then if you solve for r, you're gonna have square root, right? You're gonna have square root 200 divided by pi h. Put the square root on top of that. Nah, ugly. But if you solve for h, there, you only have that. Okay, 200 over pi r square. Okay, now much cleaner than r. I'm gonna drop that exactly right there. Okay, drop that here. That blue one, that green one. Okay. Time, don't forget the parentheses. Okay. I want you to simplify that a little bit. And find the critical point. Now you're done. Technically, this problem done. It's set up like that. It's set up like that. Nothing more you need to do, right? In terms of setting up. Now you have the surface area as one variable. Simplify, take derivative, find critical point, done. Okay, let's go. Try that. Simplify first. Don't try to take derivative right now. Simplify. A lot of things you can clean up. You can clean up a lot of things. Want to minimize. Simplify, huh? Simplify and then derivative. They don't come by yet. Look at this. See the pi? Pi? Cancel. R squared. Cancel. 2 times this. And they don't come. When you do that, they don't group them. Okay, don't group them. Okay. No, they don't cancel that. They're completely separate, but this plus. They can. Okay, simplify. Pi, right? 1 r on the top, 1 r on the bottom. Right, and so that number 2 times 200. So I have 400 over r. And over here, 2 pi r squared. There you go. That's how you combine them. Okay, so now you have surface area. You want to minimize that. In other words, you're looking for local mean. Okay, in calculus term, find local mean of that. Local means, that means derivative. Okay, derivative. Prime. Actually, I'll let you do the work. Practice that. Derivative, term by term, that's 2 terms. So that's why don't try to group them. Simplify, that's enough. Okay, think about this. If you group them, it become a big fraction, then you have to do the quotient rule, right? If you cross multiply this one, join them together, if you group them, which I don't recommend, Q into one fraction like that, right? Then the next step, you have to do the quotient rule to this, which is very ugly. You don't want that. But over here, Just term by term. That, remember pi is a number. R square. Okay, what do I have here? I have
2R.
4 pi r. Okay, the next one would be just 1 over r with the number 400. Right, 400 still there, constant there. How about the 1 over r would be
1 over R squared.
negative 1 over r squared. Keep that in mind. Negative, there's a negative in there. Okay. Negative 1 over r squared. There you go. Easier to take the derivative. Next, you set that equal 0. Set that equal to 0 to find the critical point. I let you solve for r. Solve for r. Then you have the critical points. Solve for r. Do some algebra. So far, there's many ways to do that. Why don't you get a pen? They don't come with a pen. They
No, thanks.
they sell touchscreen.
No,
They sell touchscreen laptop now. They ask you
I
to.
tried, but they don't have any. I'm like, okay.
Oh. Okay, so 4 pi r minus 400 over r squared equal 0. Right. All right. So for r, how do I do that? There are many ways, to be honest. There's many ways. Okay, so 4 pi r equal 400 over r squared. All right? Move to the right hand side. That's 4 and 400. Right. Pi r equal 100 over pi over r squared. Divide both sides by 4. I'm looking for r, so cross multiply. Multiply both sides by r squared. Multiply both sides by r squared. All right, multiply both sides by r squared. I have pi r cubed equal 100. Divide both sides by, almost done. Divide both sides by pi. And to find the radius, I just have to put a root. Okay. Right. Right. Right? No. No. Why?
No plus or minus.
No plus or minus. That's just a cubic. No plus or minus. That is a cubic. Square root, and you plus or minus. Okay. Let's say somehow you have this. Right? For example. What next? Square root. Easy. Plus or minus? Right. Nah. No. Think of the nature of this problem. What are you looking for? What did this stand for? Radius, right? In a real world problem, what is negative 100 centimeter? Right? Or somehow you work in a problem with time. And this is a second. Negative 5 seconds. What? You going to the past? Right? No. Right. Depend on the problems. Okay. All right. So one critical point. How do I know this is minimum or maximum? The test. Okay, so test. You can pick either one of them. However, before you do the test, I want to give you a hint. Here as a prime, as a, okay. This is basically cheating. Okay, this is basically cheating. I'm going to give you a way to cheat, educated cheat. Okay, a good way to cheat the system. Okay. This is how you set up. Okay, this is how you set up. I'm not gonna even do the test point, blah, blah, blah. Okay. I'm gonna finish this table right away. I'm gonna finish this table right away without plugging in. I see some of you work around, see some of you punch in calculator, which is good. No problem there. But I'm gonna finish this table right away without even test the number. How? If I ask you a question, is blah 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 true or false? Okay, think it critically. How? If you have this question, how many options you have? Two options. You have two options. You either have to answer true or false. But if I ask you this, whatever that inside has to be, you just have to prove it, right? Has to be true. What are you fighting? You try to find the minimum surface area. No matter what you do, right? You have to end up with something minimum surface area. How do I draw that? How do I visualize that in here? This or that? Which one? The one on the top or the one on the bottom? To have the minimum surface area. Okay, let's say this. Is that minimum surface area? It's pointing to the local max right there. To satisfy the problem which we are looking for, it has to give you this. Right. I didn't use test point. I use what I know. I know that I need to have a minimum right there. I need to have a minimum surface area. I work my way back. It has to be like this. If you punch in calculator, it go the other way. You screw, right? Intuition. So minimum there. There you go. That is the radius. So that when the radius is that, you have the minimum. Okay. And then the height. Find the height. Where's the height? The height is 200 divided by pi r square. So 200 divided by pi r square, which is 200. I don't need you to simplify, so put the whole thing inside. It's ugly, but it's still an answer. There. Don't simplify that. So this will be the height and the radius, so that you have the minimum surface area. And because you have minimum surface area, you're going to minimize the cost. Okay. Any question? Okay. Another way to recognize if you're on the right track or not is to look at your function. Sometimes your function really easy to recognize. See in the beginning. Okay, where is that? I'm going to scroll up. I'm going to scroll up a little bit. Okay, you done writing? Okay, I'm going to scroll up. Here. This problem. I'm going to zoom out. Do you believe that? Seen from here, seen this line. See right here. Before I even take the derivative to find the critical points, I know that this has minimum or maximum right away. This one right here, this line single line, right there. That. You know right away you have maximum or minimum. You should know. Your pre-calculus knowledge should back up that.
So maximum is a negative cubic or negative quadratic.
There you go. What kind of function is that? What kind of function is that? Okay. Somehow I find this. Actually, also I learned math education too. I learned a couple of classes in there. Just learn about the behavior of students, like how students think, how you explain, how a minor change confuse student. Looking at this, nobody can tell anything. But somehow change to this. They suddenly recognize it. Familiar now, right? Okay. Right? This one over here, and that is a parabola, right? Quadratic. This or this? The one, right? That negative. And because it looks like this, maximum. You should know your answer right away. I'm about to end up with a maximum somewhere in there. Right? And indeed, yeah, it's also the movement of a parabola. If you draw this, if you graph this, you're going to maximum L equal to 1000. Okay. All right. You see how it's all linked? Well, pre-cal, calculus. Derivative tell you that. Pre-cal, that's a parabola, tell you this. That's the vertex. You basically can do the vertex formula, right? Vertex form h over 2a, negative b over 2a, right? The vertex h and k, you can also find this because that's a parabola. Okay. Take break 10 minutes, come back. Okay, we're gonna finish. You're gonna work on this problem. You're gonna work on a lot more. Okay, when you go back, go to your room. I'm gonna return your exam too. I'm gonna practice. Okay, practice. I'm gonna return your exam. We're gonna have a lot of discussion about your exam. Yeah, have a discussion about your exam. Real talk. Real talk.
I saw it. For 7 days, I told him to call it because it was impossible.